Now we're going to look at calculations involving the colligative properties, specifically the colligative properties of freezing point depression and boiling point elevation. In order to do that, we're going to define a new way to measure concentration, that is molality, which is a small m, and that is moles of solute divided by kilogram of solvent. So molality is another way to tell concentration. So the first example, calculate the molality prepared by dissolving 10 grams of NaCl in 600 grams of water. Well, molality is moles of solute, which in my case is NaCl, divided by kilograms of solvent, which is water in this problem. So we have 10 grams of NaCl. That needs to be in moles. So we need to divide by the molar mass of NaCl, 58.5 grams per mole, divided by kilograms of solvent. 600 grams would be 0.6 kilograms. So the molality, we can just label this as a small m, is 0.285 m. 0.285 molal. Next example, how many grams of lithium bromide must be dissolved in 444 grams of water to prepare a 0.14 molal solution? Well, I have molality equals moles over kilogram. I want to solve for lithium bromide, which is my solute, so I need to solve for moles. So rearrange molality times kilograms, 0.140 molal, times the kilograms of solvent, which is 0.444 kilograms. It's going to give me moles, 0.0622 moles of my solute, LIBR. I need grams, so I need the molar mass. And 1 mole of LIBR, 86.8 grams. Multiply to get the mass of my solute, 5.4 grams. We will also look at mole fraction. Mole fraction is a ratio of the moles of a particular solute or solvent to the total number. And mole fraction is signified with an X. So let's look at a couple examples with mole fraction. So it's moles over total moles. So if we're given grams, the first thing we need to do is convert grams to moles. So we have 300 grams of ethanol. Convert that to moles. Molar mass of ethanol is 43 grams per mole. So we have 6.97 moles of the ethanol. And then we have 500 grams of water. Molar mass of water is 18. So we have 27.78 moles of water. Okay, so now we have moles. Now we can get the mole fraction. Mole fraction, we would write it like this. For ethanol, C2, that should actually be H5OH. There's a typo there. C2H5OH. We're going to take the moles of ethanol, which is 6.97, divide by the total number of moles. Well, if I add the total, we've only got 2 substances present, so the total is 34.76. So 6.97 divided by 34.76. So the mole fraction of ethanol, which is the X, is equal to 0.2. And we just leave it as a decimal, 0.2. I also want the mole fraction of water, so X of water I'm simply going to take the moles of water, 27.78, divided by the total, which is again 34.76. And here's what these numbers tell me. The solution is 20% ethanol and it's 80% water in terms of moles. And these have to add up to 1, and if you add 0.2 to 0.8, you get 1. So that's how we get mole fraction. It's basically a percentage of moles. Let's look at one more. We've got 3 substances here, the mole fraction of each component. They're in grams. So the first thing we have to do is convert grams to moles. I'll go ahead and write down the numbers. 42 grams would leave you with 1.31 moles of the CH3OH. 35 grams of ethanol would leave you with 0.81 moles. And then 50 grams would leave you with 0.83 moles. So I just did that conversion, dividing by the molar masses. So if I want to find the mole fraction of the CH3OH, I'm simply going to take the moles of the CH3OH, which is 1.31, divide by the total. Now the total, when I add these 3 numbers together, gives me 2.95. So divide by 2.95. The mole fraction of CH3OH comes out to 0.45. Similar calculations for the others. Mole fraction of C2H5OH. We're going to take the moles, which is 0.81, divide by the total, which is 2.95, 0.26. And then the mole fraction of the last component, C3H7OH. We're going to take 0.83, divide by the total, and we get a mole fraction of 0.29. And if you add these numbers together, 0.29, 0.26, and 0.45, they will add up to 1.